Okay, so I want to do a topic called isotopes, and I'm going to flip back and forth between my whiteboard and this screen so that I can use things like the periodic table. See what I'm doing over here on the right? Periodic table or the calculator, right? Or the data tables. I want to be able to use that, but I also want to be able to write over top of it. So I'm going to go back and forth, all right? So let's start with the whiteboard, and let's read the question together. It looks like, let's get a pen here. Okay, backwards. Let's get a little bigger. Okay, so it looks like we're, want to talk about isotopes. It looks like we're being asked about the isotope antimony 123 or SB 123. And you don't have to know what these things are. It doesn't even matter. But you do have to know what SB means and what 123 means. So let me take you back to something that we learned in a previous conversation, and that is that these symbols can look like the symbol notation looks like this, where you've got X for the symbol, and then in the top corner you've got the mass number. In the bottom corner, you've got the atomic number, Z. Here, you've got the charge, which I'm going to write as C. And here, on the bottom right-hand corner, you've got the N, the number of particles in the species that we're talking about, right? So, for example, if I do something like that, H2O, what does that mean? That means that the N, right, goes with that right there. That means there's 2 hydrogens for every 1 oxygen, right? Other things that we need, we don't write the 1 if it's there. There's other things that we know about that. And if the charge is 0, we don't write that out, right? Okay, but importantly for this topic, we don't really care so much about that. We care about this, X and the mass number, and the atomic number. And the mass number is equal to the number of the protons plus the number of the neutrons. And the atomic number is simply the number of the protons, right? So what we can do is we can take this, any symbol that we have here, and we can say, all right, well, if this is antimony, I'm going to go back and forth with my colors. If this is antimony, I'm not sure if I've ever heard another chemist say that. So I might be saying it wrong, and you know what? I really, to be honest with you, do not care. All right, so if it's antimony and the mass number is 123, let's go over to the periodic table. I'm going to click over to that other screen. Let's look at the periodic table. And we find antimony, and it's right there. It's number 51. You see it? Okay, number 51. Take your time to find it, of course. Doesn't matter if you know where it is. You've got your periodic table here. All right, so if it's 51, that means that the atomic number is 51. That means that the number of protons is 51, right? Well, look over here. That means that the number of protons is 51, and the number, so if that's 51, and this is 123, right? This must be plus, let's say, N. And so N is equal to 123 minus 51, which I can't do that in my head. It's got to be like 72, I'm guessing. 123, I can't do that in my head. Yeah, it is 72. All right, so that's the number of neutrons. It's 72. 51 plus 72 is 123. That's right. Okay. So let's go over here, and let's say the number of protons for antimony is 51 because it's antimony, right? It's always 51. And, how am I going to get that down there? Okay. And the number of neutrons, it's a little difficult to see, is 72, right? Okay, let's check that. Let's do one more real quickly. That was kind of fast. We'll try another one. And I'm just going to go, okay, so this is dB. Never even seen it before in my life, dB. But I do know I can find it on my periodic table, right? dB, probably if it's 270, it's something big. Okay, there it is down there. Dubnium, never heard of it. Honestly, never heard of it. Not kidding. Dubnium. That's an awesome name. But looks like its atomic number is 105. Okay, so you see it down there, 105, right there. Okay, so This, if it's 270 and 105, let's go over here to the right? And so 105 is the number of protons plus the number of neutrons is equal to 270. So that's a plus sign right there. It looks like a multiplication sign. So it looks like the number of neutrons then is going to equal 270. 270 minus 105, which I'm going to say is 165. Okay? And I don't think I'm going to explain anything else after that at this point. Let's see. The number of protons is 105. And the number of neutrons, a little clunky here, nope, not 265, 165. Let's just make sure those add up to 270, and they do. And since they add up to 270, we're good. All right, hope that helps. Trying to keep this video short. I think you got the main point. That number up in the top left-hand corner is the number of protons plus neutrons. And the number of protons is the atomic number. Good luck.